Namaskar, RVD here, and a very warm welcome to my YouTube channel. Here we will be going ahead with the next video of my playlist, a course on analysis of algorithms. Maybe I'm putting the next video after a very long time. Started with this list with the aim of giving you a good insight towards a very important subject called analysis of algorithms. But due to certain problems, I could not post the videos immediately after I've started with the initial videos. But nevertheless, now maybe I'll try putting a lot of efforts and making some good videos in this particular playlist so that it will help you in preparing this subject. So in this video, if you remember in the previous video, we have come up to the big O notation. We've started with asymptotic growth functions and we had completed the first one, that is big O notation. So in this video, we'll be going ahead with the next one, that is omega notation. So let us start with the video. Now to start with, what is omega notation? Okay, so let us first look at the definition. So omega notation, as you can see the symbol, this is the symbol for omega notation. So f of n is omega of g of n, or how do I pronounce it? I would say f of n is lower bounded by g of n. Your omega notation is also called as a lower bounding function. Big O was upper bounding, whereas your omega is lower bounding. Because it is lower bounding, it will be generally preferable to present the best case. Okay, so f of n, that is your function that you're trying to measure, f of n is lower bounded by g of n if and only if. Now imagine f of n is lower bounded by g of n. That means that g of n with the given constant, if you remember from the big O that we had used a constant called c. So here that c dot g of n should be on the lower side because it is supposed to use for lower bounding. So you can very well see that here I would have c dot g of n lower bounding f of n. Okay, so let me repeat. F of n is lower bounded by g of n if and only if my c dot g of n is less than or equal to f of n for all the values of n greater than or equal to n0. Okay, don't get confused, it's a very simple thing. When we had a big O or we had upper bounding, okay, when we say f of n is upper bounded by g of n, my c dot g of n was on the higher side. Whereas now I have f of n lower bounding g of n, or f of n is lower bounded by g of n. That means my c dot g of n should be on the lesser side. So when can I say that? मैं कब बोल सकता हूँ कि f of n is lower bounded by g of n? When c dot g of n is less than or equal to f of n. And that's the basic concept. Now here we have two constants, c and n0. So we'll be saying where c and n0 are positive constants. Okay, so it goes quite hand in hand with that big O notation. So big O was upper bounding, here it is exactly opposite, that is lower bounding. So I repeat again, f of n is lower bounded by g of n if and only if my c dot g of n is less than or equal to f of n for all the values of n greater than or equal to n0, and where my c and n0 are positive constants. Okay, so that's the definition. Okay, let us have a corresponding graph for the omega notation. So you can clearly see, again we had done that in big O also. So this is something we will be using number of inputs and this will be for time. Okay, so I'll have two things like, let us say this is one and this is other. So you can see now, here this will be f of n and this will be c dot g of n. Obviously that is happening for this threshold which we would be plotting as n0. So you can clearly see we don't know what happens for the values of n less than or equal to n0. But for greater than or equal to n0, my c dot g of n will always be less than or equal to f of n. Okay, so let us take an example. So we have, let's say, f of n equal to 7n square minus 5n minus 8. Okay, you remember we have done that, similar thing we have done that for big O also. Okay, here if I take positive terms for this, then it becomes very easy because we want to go for lower bounding. So I have taken the negative terms here. Okay, so let us see. So what we need to do, we need to prove, or we need to show that f of n is omega of, you know how to do that? The highest exponent term, 7n square. Drop the coefficient. So we are left with n square. So omega of n square. So this is what we need to show. So by definition, it would be c dot g of n less than or equal to f of n. You know, that's what I need to show. So now what is c dot g of n? So it will be c into n square less than or equal to 7n square minus 5n minus 8. Okay, so obviously I want to show that it is less. So the obvious value of c is going to be 6. That means I have 6n square less than or equal to 7n square minus 5n minus 8. Okay, so obviously if 7n square goes on this side, it will be minus n square less than or equal to minus 5n minus 8. So if I multiply both the sides by minus 1, you know the sign changes. So n square should be greater than or equal to 5n plus 8. Okay, let us check now. So see, n square greater than or equal to 5n obviously will satisfy this for n equal to 5. But we have plus 8. So there has to be at least one more. So the obvious value of n for checking is n equal to 6. So let us check. For n equal to 6, we have n square, which is 36, and we want to show that it is greater than or equal to 6 5s are 30, sorry, 6 5s are 30 plus 8, 38, which is obviously false. So this is not going to work. So n is equal to 7. So you can say it is 7 square 49 greater than or equal to 7 5s are 35 plus 8, 43. Yes, that's true. So it's going to work for n equal to 7. And you know mathematics, if it works for n equal to 7, it's going to work for all the values after that. So that's it. So I would say therefore my f of n is equal to omega of g of n. Okay, and this is true for the values of c equal to 6 and n0 equal to 7. Okay, I guess you've got all these things properly. If you have any doubt, okay, कुछ भी अगर अपने को confusion है, you have any doubt and you want to ask me anything, you can very well put it in the chat box. Now what I'm thinking is I would give you a couple of questions and maybe you can try and you can put the answers for that in the chat box. That will be wonderful. Okay, so yes, that's the video about. So before I leave and before I say thanks to you, so question number 1 for you, let's say f of n is equal to let us have 8n square minus 5n plus 3. Okay, so what all you'll do, you'll solve this and you're going to put the answer, you will say answer of question 1 and you're going to tell me, obviously you have to prove this as omega and you will be telling me what is the value of c and what is the value of n0. Similarly, let us have second question. So f of n equal to 5n square minus 12n plus 8. Okay, so that's the second one. Here also I would like to know about the value of c and n0. Okay, so yeah, coming back to the current video. So that was about the second asymptotic growth function, omega. I've already said at the beginning that there was a huge gap between my previous video and my current video. So please bear with me and I'll be putting more videos. Okay, so I would request you to watch all those videos, like them and share with all of them. You know, this is one of the very important subject, analysis of algorithm from the engineering perspective. For computer engineering students, for IT, and even for the other students who are interested in algorithms. So that's a humble request. If you know that those people are preparing for analysis of algorithms, then do share this particular playlist. You can even check my other playlist as well. I have done a decent work on data structures. I'll be adding more videos to that as well. I have done a good amount of work on C programming as well. Okay, so there also I've done a lot of good work and a lot of videos are being uploaded. So a sincere request to everyone to check my all the playlist, subscribe my channel if you have not done that so, and help me in spreading the knowledge all over. So that's it for the current video. Thanks a lot everyone, and as usual, a very happy learning.